Okay, and we are live. So, let's get into it. So, just to recap, we've been working on a parser. I mean, on a compiler, and we're currently working on the parser. So I have updated since the last stream. Sort of just updated the README and added basically the main goal of the project. So I decided it's gonna be that the language is capable of writing fizzbuzz. And that's the minimum. Once that is implementable, then I'll sort of just I'll decide where to go with the language there. I'm gonna stop developing it or what. Yeah, so I wrote that all out here, and it sort of just shows like that's the minimum amount of stuff that it's gonna have. Yeah. So I will actually post a link to this in the chat. There we go. In case anyone's interested. And then a few other things I've done. So let's actually I run the file main. You can see that I updated the print tree, so it's just a bit more clear. So here's the root, and that's program. That's the value of it. And then to the right of that, it attempts to print to the left first, but if there's no left, then it just goes straight to right. That's the exit. And then to the left of that, it is the open parentheses, and then to the left of the open parentheses, it's 1. To the right of it, it is close parentheses, and then to the right of the exit, it is the semicolon. So that's the structure that we have basically. And you can tell it's indented by 1 based on by 1 space based on what the parent is. So the parent, this is the parent of these two down here, basically. Yeah. So let's see. I think that's all I've done. Parser. Let's see. All right. Let's see. So yeah, I've been thinking about it and doing some research. So I think this structure, for the most part, will work. Once it gets more complicated, we might have to change this where we don't just have a right and left node, but instead we have like an array of nodes. But we'll get there. For now, we'll keep doing it like this. Let's see. Alright, let's see. So here, basically, what we're going to do, I'm going to kind of refactor this. Because this is technically working now. It does output the tree. It just won't work very well if we change this. Basically, we're going to go through each token, and then based on the token that it is, right? So if it is, I'm going to change this, but if it's like a statement, then we'll go through the different types of statements. It could be so like an exit statement, and then we'll go through all the possible things that can come after that. And for the exit statement, it's pretty black and white, right? There's going to be an open parentheses, and there's going to be the closed parentheses, and there's going to be the semicolon at the end. The only thing that can change is the number in there. So that's sort of how we're going to handle it. So I think what I'm going to do, really quick, let's go to parser, Lexer. Let's open that, and I'm going to use these same tokens instead of the ones that we defined here, just because that's going to make it a bit more clear. So instead of no types, we'll be token type. I think, yeah, token type. And then we're going to have to change things once we do it. Let's see. So basically, let's see what we have. Token type. So yeah, let's actually add. Let's add a token called beginning, and this is only going to use in the parser, not in the actual Lexer. So now I have to modify the Lexer file, the main file, and we need that. So I think I can actually just define this in the .h file, but I'll change that later. So I need to also add the case here. So just case beginning and begin. So we should never reach this point, but we could technically, so we have to handle it. Yes, and then in here, this can stay beginning, and then instead of statement, this is keyword, which I think I should probably rename that just to statement, because that might be a bit better, but not now. And then this is separator, yeah, extra, so yes, separator, and this is just int separator. Okay, and then I think it'll all work. Okay. Alright, it all seems to still be working. So now I'll leave this here, and we'll do a switch statement. Current token type. I need parentheses. Okay. So we're gonna have case of keyword, and then we'll implement stuff here, and then we'll have case of separator, and we'll implement stuff here, and then so I don't want to implement all of them, all the different cases here, or no, maybe I do. All right, well, let's see. What is the other one? Int. Yes, case int. Okay, so we're gonna look at the keyword, and we're gonna do if current token, we need string comparison. Current token value is the same as exit. Then we're gonna basically walk through the steps. So the next one, or yeah, so we need to actually create the node. So we know when it's exit, it's gonna be the root node, because that's where it's always gonna be. So root right equals exit node, and so we'll just basically do the same thing we implemented here. Alright, so then that's going to create the node, and then we're going to want to current token plus plus. And then we want to check if the next one, if the current token now is open parentheses. If it's not, then we can just throw an error, because it's always going to be open parentheses. So now, yeah, if current token value does not equal open parentheses, current token type does not equal separate, because there's could be a chance in the future, once there's strings and stuff, that it is the open parentheses but it's as a string, so we got to check both. Something is not right. Okay, there we go. So actually this has to be string comparison, because it's a string and not just a single character. Yes, open parentheses. Okay, then we're going to do this, which we did here. So I'll just copy that. And something else that we are going to have to handle eventually is actually line numbers for error handling. But I don't need to worry about that yet. So current, let's see here. Yeah, we want to set current equals exit node as well. Current equals open current node. Okay, and current plus plus. So now we can do else, because any other condition is not going to work out. So we're going to say printf error invalid syntax. So that's all we'll print for now. And we'll return 1. Okay. So let me just look at this and make sure it's all good. Exit 1. Yeah, we'll do exit 1. Okay, exit 1. Yeah, actually, so I like the way I did it here better. So we don't set the current equal to that. And now we'll do if the next one, for now we can just check if it's not an int. If current token type does not equal int, then, okay, we want to equals that. Then we'll do that, else we're going to do the same thing. So we could probably make a function for errors, and they are mostly the same, but not going to do that right now. So yes, so now we can do the int. That's what we have here. Expression. Okay. Oops, sorry. Okay. And now let's see. So node. Let's make sure this is all still good. All right, and then the last one. Well, there's two more, I guess. So yeah, current token plus plus. Okay, now if it is kind of nested, but that's all right, I think. Current token type string comparison of current token value, and we want it to be close parentheses. I actually did an error here. Alright. And then else, we're going to print the same thing. Okay. Let's see. So now we can take what we have down here, this one, yank that. Okay, there we go. So close parentheses node. Okay. Alright, and then current token plus plus. Now we have the last one. So we need to make sure that it's a semicolon. So if value semicolon and current token type equals separate. Then else syntax. Okay. So now we want to do the semicolon one, which is the last one that we have here. Okay, actually that's too far. Okay, that's better. So semi-node, current dot right. Alright, yes. And then after that we can just break because that's the last thing. So let me get rid of this. Okay. And I'm pretty sure that's always going to be the last thing. So yeah, so now we can break after that. So it should work. Alright, got some problems. Alright. Alright, I need to add the cases for all of them. And if we get these, then I think we can just return an error because we don't want these. Unused variable left. Alright, I can get rid of left and right. Oops. Okay. Where did I mess that up? Stirp. Stir count. Okay. Pointer and int. Whoops. This is int. There we go. Okay. Invalid syntax. Oh shoot. Alright, let me actually I will print invalid syntax on semi. And then this one's on close paren. Let's do close. And then on int. And then we can know where it's based. On open. Open. Alright. So that first one is wrong. So let's see. Where do we... Let me go down to the Lexer. Whoops, went past it. Alright, generate separate. Yeah, that's where we do it at. Let's printf current token value. And let's see what it says. Okay. So okay. So we need to make sure it's 0. Why don't we have to do it there? Alright, let's see what the value can say. Alright, so it is capital. Alright, let's see. Alright. Alright, let's now change the file. And let's do something like that, which should be invalid. Okay, on open, that's good. And then if we do that, it should be on close. Alright. Okay, and there should be an error with that as well. No, it just breaks. Okay. Let's see. So why does it break? Why does it seg fault? We make it here. Current value is null. Okay. Oh, because we can't do string comparison if it's non-existent. So then it shouldn't print this. Yes, alright, so we need to do also current token null. Okay, so how do we check if it's null? Okay, so we're going out of bounds. That is the problem. So how do we check that? Zero. So it's not. Let's see. Perhaps. Whoops. You need to do and, not comma. There we go. Type. Oh shoot. All right. Okay, let's see this now. Alright, so we get the error now. Let me make a function for printing errors. Let's see. So we need error type, and then alright, that's all we need for right now. So we'll just print error. Okay, and then we'll exit it. Then we can make this look a little bit else. Print error, no, invalid syntax on, what is it, open? Is that what it was? I don't remember. No, this is the same. On open. That's close. Alright, we'll just change this to print error. Print error. Alright, and then we'll do another print error here. Okay. Alright, so we only have to worry about that with the, actually that's probably not true, because if we get rid of this one now, then it breaks again, right? I messed that up. Now it won't work, right? Yeah, okay, so we need to handle that for every one. So there's probably a better way about doing this, but I'm not gonna worry about it too much now. Just need some basic error handling. Syntax on close. This one's supposed to be semi. We don't actually need new line here. Okay. And then same thing here. On int. And then the same thing. Whoops, no, this is open. This is in. And this is closed, so I changed it, but it was wrong. Okay. No. I was right. It's just because we're looking at the next one. So yes, this is closed. This is in. And then we have one more for open. Okay, now it should work. On close. Alright, and then get rid of that. Now it'll be on in. And then on open. And if there's nothing, then it's just like that's an empty file. So it doesn't generate anything. Okay. So now we can generate the tree. And I think we have enough. Actually, let me do this. Yes. Alright, so we just don't generate, but I think we can check that. Whoops. If we go here, we have the case. Case in. So we can just print f integer. And it should detect it. Oh. Alright, so we just want to do at the end, we want to break. No. Okay, let's see. So why would it fall through? Oh, case separated. Oh, this one. Okay, there we go. Not sure why that one specifically, but alright. And yes, alright, so we do detect the integer. So, I mean, we can't do that because of how we implemented it. So we can't do like exit 1 and then generate 2 of them because, oh shoot, why does that break? Alright, I'm not sure why that would break, but we don't really need to worry about that right now because we're generating it from the parser. So now I think we can kind of make the code generator now, where we basically traverse through the tree and generate the code based on the nodes. So let's just code generator dot h and code generator dot c. Well, so first let's kind of look at what the assembly will look like. So I'll just make a directory for the assembly, and then this is where we'll make all the tests. So vim test.asm. Oops, no. And then we'll open it up here. Test.asm. There we go. Alright, so we need, let's see. So we do need that. But I think we have to do section text. And then, is it, I think it's rad1. Because that's going to be moving to the, actually, I can find that. Linux syscall. So basically we're using syscalls. So if let's see, this is a good one to look at. It's light mode. Maybe we'll change that. But yeah, if we look here, so oh shoot, is this RAX? I don't know, we'll test it out. I think it is RAX. You can see the first is right. Basically, we're gonna move into, no, oh shoot. No, we're not doing 1, we're doing 60. Because 60 is exit. Yes, 60 is exit. And then the error code, we move the error code into RDI. So let's do move RDI 1. So that, and then we'll just run syscall. And now, let's see if I can get the assembly to work. NASM elf 64 test.asm test or test. Oh shoot, no, remove test. because we want, that's the .o file, test.o. Okay, and then we do the linker, test.o, test dash o test, and then, nope, we broke it. All right, what is the problem? Let me see. I was testing with it earlier. Exit that. Alright, section, global start. I don't see what's wrong. Oh, I do see what's wrong. There we go. Now it should work. Yeah, so if we run this again, NASM, and then, okay. And then if we run test, and we echo, let's see, we're gonna echo that, and that's the error code, there, 1. So we can change this to 12, and it will do 12 once we recompile. Alright, so let me actually move that into a build script so I don't forget. Build asm dot sh. Okay. Build asm. Alright, so let's do nasm-f-l64 test.asm-o test.o. And then ld, let's see, ld what? ld test.o test. Alright, and then I think, okay, and then if we run the test and we echo, alright, seems to be working. Seems to be working. So basically that's what we're going to generate. Alright, yes, it's working. So we're going to generate this, and then I think from the code we can call the commands that we need, like the nasm command. So I can actually close out of this. So that's what we're going to be doing. I can close here. Alright, let me open that up. If I could do it. Okay. Let's open the code generator. .c. And we'll just include h. And then we're going to include the parser .h. Alright. So now we just do, let's see, in here. So I don't know that we're going to return anything from this really. Well, maybe an exit code. So generate code. So what we're going to take is the tree, the root of in here. Let's see, node. Let me make sure the parser. Let me make sure I got this. I do not, so I need to declare some things in here. Take that. Okay, and then we also need all the functions that we had, because we might be using them in here, I don't know. We probably will actually, at least some of them. Like that. And print air. We'll probably use, that could probably be in the main file. We could probably move it there. Okay, and alright, we already have the parser, so that should be good. Now when we're including it, we should be able to reference it. So what was it called? Node root. And for now, we'll just printf no errors. Just make sure we don't have any errors. And let's open code generator.h. getting kind of messy. Generator H, and then negative. And we will just put this in here. Okay. Now, going to the main file, opening another one, we'll include that in here. Code generator. Alright, now, alright, there's no errors. And then if we run, we never actually call it though, so let me do that. After we do all this, we'll call generate code. And we will just for now we'll just pass as test node. Okay, that's not gonna work. Let's see. I probably spelled something wrong. Well, that's wrong. Alright, let me compare here. I don't know why it's not working. Expected expression before node. Are we not including? Okay, so that is working. Let's see. Alright, there we go. That's probably what the problem is. Alright, well now there's an error because of the way I set this up. Nope. Alright, that's still not what the problem is. open this. Let's see. I guess I want to change this. Not gonna be a token, it's gonna be the node. And we're gonna return the root node at the end, all the way at the end. Let's see, I'm trying to figure out where the errors are coming from. Or what's causing it. Okay. Probably spelled this wrong, didn't I? Code general f.h. I know what the problem is. Actually, I'll open it up. I forgot to add it here. I am very stupid. Okay, now. Alright, now there's errors because of other problems, but we fixed that one, so that is progress. Let's see. So it's just C type. Alright, let me actually return the row. Okay. Parser. Token type is unknown. Flexor. Let's see. I'm not sure why it is doing that now. Perhaps I messed something else up in the build file. I know there's a better way to do this, but I don't remember how. link. So the parser is still working. I don't quite understand what that means. That's unused. We can do that. Something like that. Okay, there we go. And then it just ignores it for now. So why is token invalid now? Because that is in our Lexer. Now I messed. Oh shoot! I shouldn't have saved that. All right, now I messed this up. Let me open the Lexer. Let's see. All right. Let's see. All right, I need to put all this stuff in here. Separator and beginning. Beginning goes at the top. Okay. Token. Okay. Okay. And then we need, alright, we have print token, generate number, generate keyword. That's all right. And then we also need to generate separator. And that's it. Okay. Lexer f.h. I don't quite understand why it would not be identified. If I take this and put this in here. Alright, I think what I need to do is include Lexer as well. Now that's gonna fix it. No. Dang. Let's see. Generate separator. No Lex. That is used. Okay, dang, okay. Okay. Why is there so fewer errors? Very clear. Okay. These are all the errors generated just from adding this file. Okay, dang, I messed something up really bad. Holy moly. Unused parameter current index. I don't quite understand what happened. Oh man, it just keeps going. Every one. I don't quite understand what happened. Now I can see again. Alright. Did I remove a semicolon? Alright. Go here. Dang, I don't understand what happened. I don't want to get revert because I didn't push the changes. Should have done that. Let me see. That's not it. Let me actually. All right. Is this the problem? That was the problem. We got 1,000 errors from one semicolon missing. Okay. Let's add back our code generator .h. Let me open it up. Alright. We'll include it again. And then we will generate code. Okay. Unknown type name. Node. X size of node. Alright, let's include the Lexer. Still doesn't know what node is. Well, that's in the parser anyway. Node. Well, it's not taking anything right now. Oh shoot, because we still have that header. Alright, let's do that. Let's see if we can get it to work now. No errors. Alright. Now let's figure out why it doesn't recognize node. Yeah, that doesn't work. Why is node not recognized? Because we use token in here just fine. And that is taken from the other file. See, because of this. Unknown type name node. It's called root. Okay. Type name node. Why? I don't understand why it is unknown. Obviously that breaks things, so we can't do that. Alright, well that breaks everything, so we can't do that. Let's see. There we go. Oh my goodness, I am... Okay. Okay, that is okay, that way. Alright, now, I think we can kind of just call the print tree on the root, and it should print the same thing. Oh yeah, we need to include, let's see, we need the indent. Let's see, what else does print tree require? And then the identifier. Alright, oh yeah, that's right, because we are not... Alright, let me go back into... I can close some of this that we don't need now. Let's go in here. So this is now returning the node, so we should be able to node test. Alright, let's try that. And then we'll pass that. Alright, so that looks good then. I don't quite understand what this means. It's because we need to and then just set it. No. So why does it think it's token? Oh, it's because we're in here. We need to change it. There we go. Now it works fine. Okay. We don't need the malloc though. And it should still work. Alright, now we can basically, in a similar way to what we're doing with the print, we can traverse through this and sort of check what the values are and generate it into the assembly code. So to do that, we're going to need to open a file. So let's do file. Here, I had this pulled up because I don't remember it always. File equals fopen, and so we want to open generated.add, and then later we'll add it so we can set the name of the file. But yeah, we're gonna do that, and we're gonna open it with write, and that should create the file. And then we'll use assert actually. Does not equal null. Yeah, I think that's right. And then file could not be open. Okay. And then yeah, so we want to, let's just, and we'll first print out the global start, or actually no, section.text. Then we want a new line. Actually, we'll do it all separately. Section.text, and yes, actually, I think that's all we need. And then we need fprint file global start, and then fprint file start, and that should. All right, we have some problem. Oh yes, we need to include assert. Okay, we got assert now. All right. Made it through. So now let's see if we have the file. Assembly. Okay. And let's just open the file. Alright, we didn't add new lines, so that's gonna be a problem. Alright, now let's try this one more time. And there we go. Alright, so that, actually, I think we want to indent it. Yeah, so we want one indent on, let's see, in here we want this to be an indented. There we go. Alright, that's what we want. And then all the rest of the code will go down there. So basically, right, we'll just check for an occurrence of each of the different token, or of the, we'll traverse the tree, and based on what it is, we'll add to the file certain, actually I did do that one, but we'll add to the file certain certain contents basically. So actually this needs to be up there. Okay. So yeah, that's what we wanted. We can close out of these for now. Alright, so let's actually do void traverse tree node. And basically I think we can do this with a wall loop. So wall node not equal null. Node equals node dot left. And how do we get back? We want, let's see, we can set, whoops, node root equals node. And I think we can do node equals, let's see, actually, alright, well let's do that, and then node equals root. And that actually I think will go forever. Traverse tree root. Okay. I already had that up. How do we... Actually, we want to f value node value. Okay. Alright, yes. So if we do this, then it should print the left value. No, then it just breaks. Okay. So it doesn't like us setting it this way. Alright, let's modify this, because alright, I'll be right back actually. I'm gonna take a break and end the stream. Alright, starting back up, I had to do something really quick. So, alright, let's see. I forgot where we were at. Alright, so this doesn't... Okay. Alright, that doesn't make it. Okay. No. And then we'll change that in here as well. Alright, and that breaks a lot of things. Okay. 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 Entry. If no equals no. There is no dot dot. So that causes the problem. Okay, so that works. So we can go to the right. Let's see. Okay. Okay, so that think perhaps we could do this. I don't know if I kind of want to. Let's see. Else node equals node right. Okay, I'm lagging. Okay, that's not good. Alright. And now, alright, that works. Alright, now it's not breaking. Alright, yes. Else if node right is not equal null, then else will break. So that's not going to work entirely. Alright, so we can print some of it. I forget how to print a tree like this without using recursion. So we can look it up. How to print a tree with a loop. My computer is not liking this. Maybe I should close some of these. I don't need. Okay. So let's see. This is. We can look at it and see. No, left and right. Okay. Let's see. Print. Binary tree. Well, I guess we could use for loops. Let's see. I don't know if this will work. Test. Okay, let's see what this does. Print test right. Oh yeah. We gotta do node equals node right. Node left. Then we can say node equals root. Okay. Test and test. Let's print the value. Value. Okay. value program, value exit, and then it stops. Alright, so this won't work. It does work. Okay, I guess this is basically just a while loop that I'm doing. I can't talk. Let's see. Alright, that's using a stack. So we could implement a stack. Let's try just doing it with recursion. So let's print it all the same way we're doing the print tree in the other one. And then we'll modify it to generate the code. So let's just kind of copy how we do it in here. Okay. We need to change this to traverse tree. Okay. And now this will do. Oh yeah. Alright, well we don't need the indent or the identifier. Okay. Okay, now, there we go, now it'll work. Okay. So now we're printing it out, and what we want to do, maybe we should have a string, or maybe it could just be like a bool, basically. Well, basically a bool. In is left. Right, so then we would pass 1 and 0. So then if it's left, then we'll know. Let me think about it. Let's just D. Okay, that's good. Good enough. Alright, so let's just make the tree that we have here basically. P, and we have exit, and on the right of exit, we have the semicolon. On the left, we have the open, and to the left of that, we have the 1. To the right of that, we have the close. So we need to work through this. So we're going to the left. Let me see. So want to look on the left, and then if is left, and do that. Else we'll do something different. So it'll all pretty much be in here. So basically, we want to check the value of each node. So we're gonna be pretty sure it's syntactically correct because that's what the parser takes care of. What if we just do node value is exit equals 0, then exit, and then we'll do if value with alright, well, let's think about, let me change parentheses equals 0. There we go. Nope. Don't need that. Do need that. Okay. No. There we go. Now I got it. Alright, that took too long. If. Alright. So let's just handle everything. Node. Actually, we don't. We need node type equals int. If node value that okay. So now we also need to pass the file that we are editing. So file, that should probably, we'll just do it here. File. We're gonna modify the file like how we do here. So let's traverse tree 0 and then file. And we'll take this okay. So we want move RDI 6, or no, it's RAX, right? So I have the test assembly code. Alright, this is what we're generating. So yeah, RAX 60, because that's the exit call. Okay, and then, alright, what does each one look like? Alright, well, so then this, we're gonna fprintf file move RDI with the value of node value. A toy, because that's ASCII to int. If you want it, well, I guess it doesn't matter. I think we can do that. And then here, well, actually we still have one more. Is the semicolon. Then, then we want syscall, because that's basically what that references. Well, I guess that's not quite right. Because we don't always want a syscall after a semicolon. In this case, we do. Well, we'll leave it like that for now. I think this will kind of generate. We do need to indent it though. let's see. Got some errors. Too few arguments. Oh yes, because we need 5 and 5. All right. Alright, I messed a thing up. Oh, yes. There we go. Alright, slash build, slash. Alright, and let's see what it wrote. This is the test one. Okay, so we did not. That is the problem. Okay. Now it should, yeah, now it generated the right thing. And now, after we run that, we can run system, NASM, 64, generated.asm, generated.o, and then system LD, generated.o, generate. Alright, and then that should, okay. Do we need the indent? Well, let's see what it generates. Okay, that doesn't work. Okay, let's look at, let's just add another new line there. Okay. Well, let's look at our build assembly. Oh, well, that's a problem. Alright, let's do div generated.assembly and then test.assembly. No new line at end of file. Whoops. No, I just messed that up. So what if we run this on the, let's do that. Let's do, whoops, I gotta spell it right. And then system -o #text. Alright, and now let's try it. H. Okay, and then it worked. So I feel like the problem is with the tab. So what if we do something like that? Let me go up here. Okay. Alright, so that works. But for some reason, this does not work, unless it works now. Cannot find entry symbol start. Oops, I closed it now. Okay. Yeah, it's all the same. I get rid of this new line here. And I'll open up a new terminal. Assembly slash test.assembly and generated.assembly. Okay, move RDI2, alright. Syscall. If I modify this now, let's see, and then NASM. And then it works. Okay. Okay, so the problem is with this. I don't understand what the problem is though. So if we don't do that, we don't do this. We build on a save. And then we run that. It's generated. Well, actually, let's remove the generated.o and generated.assembly. And now we run it again. We generate the assembly. And then if we run ASM 64 assembly, that shows generated.o. And then we do ld generated.o generated. Then it works. Yes, alright. What if we make and then we open, we build, and then we run it all in here. Okay, and then what if we call this from here? /build assembly.sh. And then we gotta, let's test it. Okay. And then if we run it, it does not work. Let's actually look up how to call NASM from C. LD doesn't work when calling from C. Let's see. How to assemble assembly from C. Because we're generating it now properly. For some reason it doesn't work. It's the right executable. I just don't understand why it wouldn't work from here. Unless we need to add like a weight? I don't know. Let's see, let's copy this. Let's search here. Okay, let's look at what's here. We don't need to do this. Is that one? Alright, well, let's see what that does. Let's do actually, let's cat dot slash generated dot, and let's see. Okay, that doesn't. Okay, so it's still empty by the time we get here. So that must be what the problem is. Well, actually, what if we do this from the main? Let's take both of these and let's open main.c and put them in here. Here like this. And now what if we still doesn't work. Okay. Something else we could change though is new line there. It's not, it doesn't fix it, but see how to call system after all other processes. Because that's what the problem is. It's calling it before that is ready. Let's try file equals fopen, and we'll open generated.assembly for writing. No, we don't want that. Then if not file error, that's okay. And then we'll exit. And now we'll see what this does. Oh, let's just do assembly file. Not assembly file. Okay. Alright, so it doesn't. It can be open. So that works. So that's the problem. The file doesn't exist, but it doesn't recognize that it doesn't exist. Let's see. system. Okay. Oh shoot, is it because we're not closing the file? That was the problem. That was the problem. Okay. Dang, there's been so many stupid problems today. Alright, so I think it worked then. So I think we can just run that now. But I'd rather... No, we'll leave it as that, because that is better. For now. We'll change. Alright, no, I don't want to... Alright, yes. And then, alright, let me remove generated, and generated.o. And now, when we run that, we get generated. And we can change our test file. We can then run it again. We don't have to build it again. And then if we run generated and we echo the code, it works. Oh my goodness. So technically, this is a working compiler that I made. And it won't work if, I think it's, I forget, it's like 255 or something. You can't go above that. $244. Alright, it's something like that. But yeah, this is a compiler. You can modify it. And it will compile this into machine code to be executed by the computer. That is epic. So now, basically we just need to add all the other things that we need. So I think the thing that makes the most sense to add first is like operations like that. So I'm not gonna do that today because I've already been streaming for a long time today. But I can think about how it works for a little. So that's gonna stay like that always. That's gonna be there. So let's go over here and let's imagine we have, actually we're still working over here. So let me make a new one. So we have the main process. This is very big. And then it breaks off and we're gonna have the exit. E is exit. And there's always gonna be the semicolon to the right. And then over here, basically the way I think it should be generated, we'll have the open parentheses. And then to the right is going to be the closed parentheses, because that's, and to the left, we're going to have the plus. And that can break off, and that'll be the first number and the second number. So then what we'll do, while generating it, is we'll go here, we have the exit, so we do the, let me open it up. Whoops. Let me change that. Let me open this. So we have the exit, so we're going to generate this. And then we are going to generate this. But for this, first we have to figure out what this is. So basically what we'll do is if we come across an integer, then we will just move or set this number to be the integer. But if it's an operator like plus, or it could be minus or mod or whatever, then we're gonna go into that and we're gonna look to the left, get that number, we're gonna look to the right, get that number, add them together, and then that's gonna be the value that we set there. And then we run the syscall just like usual. So basically that is what we need to do next. And once you add one of them, like basically what we can do is we can do if it's an operator, once we get to this point, then if else, we'll be able to just, or if it's an int, we'll do this. Else, if it's an operator, we're gonna figure out what kind of operator it is, and then perform the correct operation on it. And then after that, we have to get into variables. Let's see, variables, yes. So something like int x equals 27, right? And then we'd be able to put x here, right? So basically we'll look at this. Int, that's our keyword. X, that's our identifier. Equals, that's a separator. 27, that's a literal. And then we're gonna put that all together and then be able to call it from there. Yeah. So I'm gonna do a lot of thinking about how this works. I'll probably clean up some of the code. Maybe add some comments. But yeah, I'll push that to the GitHub. I'll push what I have now to the GitHub. Let me get that working lexer, parser, and code generator on a basic, not a basic, on a simple exit syscall. Actually, I need to modify the git ignore. Let me do that. Git. I can't open it. Alright, let me exit out of here. Alright, so we don't want any of that. We don't want generated.asm. We don't want generated. We don't want generated.o. Yes, and I think that's all. Okay, and then it didn't work because I added it before. Alright, let me actually remove generated.asm. I'll remove the assembly for now. Generated.o. Okay. Git and dot. Fix the errors. That's descriptive enough. Alright, there we go. Now, okay. Now it is working. So, I forgot to update the readme, so I'll do that now. Currently can fully compile an exit syscall. More to come in the future. Alright, now okay. Yes, indeed. Very cool. Yeah, so that's all. I'll put this in the chat again, even though I'm ending the stream now. Thanks for watching.